In this question, a graph is given. The x-axis is time, the y-axis is position. So the graph shows how the position of an object varies with time in the time interval from 0 to 3 seconds. The question is, at which point does the instantaneous speed of the object equal to the average speed? Before we solve this question, just remember instantaneous speeds are to be found using the gradient, but the average speed is to be found using the basic formula. So let's figure out the average speed. Average speed, if you recall the formula, is the total distance traveled divided by total time. So how do we find the distance traveled? So at time t is equal to 0, you can see the position is 1. So let's write it down on the left. At t is equal to 0, let's say r stands for the position. R is equal to 1. And then if you look at time t is equal to 3, the value of r is approximately 3.5. So what we can see is if I can draw a dotted line from D on the y-axis, so it's pretty much close to 3.5. So we can write at time t is equal to 3, the position is 3.5. So what will be the distance traveled? It will be the subtraction of the two, 3.5 minus 1. So let's write down the distance traveled will be 3.5 minus 1, which will be 2.5 meters. Now, in the exam, students have this tendency of taking 3.5 as it is as the distance. 3.5 is not the distance, it is the final position, and 1 is the initial position. So, if we subtract the two numbers, that is how we are able to find the distance traveled. So, average speed is distance upon time, distance is 2.5. So, let's write down 2.5 in the numerator, and the denominator we have time, which is 3 seconds. And now if we simplify this, we are going to get approximately 0.8 meters per second as the average speed. Now all we need to check is at which of these points A, B, C or D, the instantaneous speed can become equal to 0.8. So how do we do that? Remember the basic concept of instantaneous speed. It is the gradient of a position time graph. So all we need to do is figure out the gradient of the graph at individual points A, B, C, and D. And how do we do that? Let's revise the concept of gradients. How do we find the gradient? If you recall, the step one is to draw the tangent, and then step two is to find the angle theta, which the tangent is making with the x-axis, and then we do tan theta. Let me explain this with an example. Let's say we have this axis system and this blue graph is drawn. And let's say the question asks us to find the gradient of the graph at the point A. So what do we do? Step one, draw the tangent at the point A. So in this case, the tangent will go like this. Hence, it is parallel to the x-axis. Step two, find the angle theta, which this tangent is making with the x-axis. In this case, the tangent is along the x-axis, so theta will be 0 degrees. Hence, gradient of the graph at this point A will be written as tan 0, and tan 0 is 0 only. That's why the gradient at the point A is just 0. Let us try to figure out the gradient of the graph at a different point. So let's say at this point. Steps stay the same. Step number one, let's draw a tangent at that point. And then step number two is to try to identify how much is this angle theta, which the tangent is making with the x-axis. So if you look at this table, the closest is, now this angle is approximately close to 30 degrees. So then the gradient will be tan of 30. And if you look at this table, tan 30 is 1 upon root 3. So gradient of the graph at the point B is 1 upon root 3. Likewise, if you have to figure out the gradient of the graph at a point C, same step. Step number one, let's draw the tangent at the point C. Step number two, can we identify this angle, the angle which the tangent is making with the x-axis? And we can observe that this angle is approximately 45 degrees. So the gradient at the point C will be tan 45, and tan 45 from this table is 1. Hence, the gradient of the graph at the point C will be equal to 1. And now let us consider the last situation where we have to find the gradient of this graph at this point. Step number one, let's draw a tangent at that point. Step number two, let's find out the angle which the tangent is making with the x-axis. In this figure, we can see the tangent is perpendicular to the x-axis, which means theta is 90 degrees. Hence, the gradient is tan 90, and tan 90 is infinite or not defined. Hence, we can say that the gradient of the graph at point D is infinite. And this is what we are going to use to solve that question. Now, coming back to the question, we had figured out the average speed was 0.8, and we have 4 points A, B, C, and D. Let us try to find out the instantaneous speeds at various points. So, instantaneous speed at the point A. what will that be? So a point A is over here. So if we draw a tangent, it will go parallel to the time axis. The angle which the tangent makes with the x-axis, that will be 0. And hence the gradient will be tan 0, which is 0. So instantaneous speed at the point A, we can write is 0 meters per second. Likewise, instantaneous speed at the point B. Now, if you draw a tangent at the point B, the angle which the tangent makes with the time axis would be close to 30 degrees. So instantaneous speed will be tan 30, which is 1 upon root 3. Likewise, the instantaneous speed at C. At C, the tangent will be making an angle of approximately 45 degrees. So tan 45 will be the gradient. And the value of tan 45 from the table is 1. At the point D, if we try to draw a tangent, that tangent will be perpendicular to the time axis like we saw earlier. So since the angle is 90 degrees, so we can write instantaneous speed at the point D will be tan 90, which is infinite or not defined. So all we need to check is at which points out of A, B, C, D, the instantaneous speed is close to the average speed, which was 0.8 meters per second. At A, the instantaneous speed is 0, so A is definitely not the answer. At D, the instantaneous speed is infinite, so clearly D is also not the answer. Now, the answer is 1 between B and C. At B, the instantaneous speed is 1 upon root 3, and if we simplify this, 1 upon root 3 is approximately 0.57. And at the point C, instantaneous speed is 1. Now, average speed was 0.8, which is closer to 1 than 0.57, which means we can select option C as our answer. At the point C, instantaneous speed is approximately 1, which is closest to the average speed, which was 0.8. Hence, we can select option C as our answer. And that is how we solve graph-based questions using the gradient method. In this question, a graph is given, a velocity time graph is given. So an object is moving in a straight line. The graph shows the variation of velocity with time. Which of the following is correct? So try solving this question on your own. Pause the video and only then look at the solution. So how do we approach such questions? Statement number 1. At the point A, the object changes its direction. That is a little tricky to find. Point number 2. At the point C, the object is at rest. This will be easier to check. If you look at the graph at the point C, the graph is cutting the time axis, and which means the velocity at the point C will be equal to 0. So let me write the velocity at the point C is equal to 0 since the velocity graph is cutting the time axis at the point C. And statement number 2 is specifying that only at the point C the object is at rest, which means statement number 2 is definitely correct. Now, which means we can eliminate option A as our answer because A doesn't even have the statement 2. Now, let us look at statement 1. At the point A, the object changes its direction. So, how do we identify when is the particle changing direction? So let me take an example. Let's say we have a box which is moving towards the right hand side with some velocity, let's say 10. Now eventually, let's say it slows down and comes to rest, which becomes v is equal to 0. At this point, let's say the block goes to the left hand side with the same velocity. Let's say v is equal to 10. Now, please remember velocity is a vector quantity. It has a magnitude as well as a direction. So initially the velocity was 10, but going towards the right hand side. So it was v is equal to plus 10. On the other hand, when the block starts to go left, then although the magnitude is 10, but it is moving to the left hand side, which means we need to write a negative 10. Negative is to signify that the direction of velocity is to the left hand side. And hence, in this example, we can deduce that the direction is changing for the block. Earlier, it was going right, then it is going towards the left. What happens when the direction changes? So, actually, the sign of velocity changes. Earlier, it was positive, then it became negative. So, just remember a basic rule. Whenever a particle is changing direction, the sign of velocity needs to go from plus to minus or vice versa. So, basically, just the sign needs to change. Now, in this graph at the point A, let's analyze the point A. Is it changing the direction? So, how do we do that? Let me zoom this picture. So, let's look at the point A. All we need to check is the sign of velocity changing or not. So, how do we do that? Let's look at this point A. So, you go a little bit to the left hand side of A. So, this particular point, and we go a little bit to the right hand side of A, which is this point. So, now let me label these points. Let's say P is the point just to the left of A, and then let's say Q is a point just to the right of A. Now remember, the direction will only change if the sign of velocity is changing. In the graph, we can see both P and Q are above the time axis. So that means the sign of velocity at the point P as well as point Q will be positive. That means the velocity sign is not changing. Hence, we can say that at the point A, the particle is not changing direction. But just in case, we need to check which point is that where the object is changing direction. Now, if you analyze the point C, let's apply the same steps. We go a little bit to the left hand side of P. So let me label that point as R, and we go a little bit to the right hand side of C. So that will be, let's say, a point S. Now, R is above the x axis, S is below the x axis. So, which means the velocity at R is positive, velocity at the point S is negative. So, at the point C, the sign of velocity is changing from positive to negative. That means the object is changing direction at the point C, but that is not happening at the point A. So, if we go back to the statements, statement number one will be clearly wrong as the particle is not changing direction at the point A. Now, that means since the statement one is wrong, we can eliminate option C as our answer. So, the answer is either B or D, which means we need to just cross check the statement three. The magnitude of acceleration at the point T, is it greater than at the point B? So, how do we do that? How do we find acceleration from velocity time graph? So, the logic is the gradient or the slope of a velocity time graph gives us acceleration. Let us understand this in a little more detail. We have to figure out the magnitude of acceleration at the point B versus at the point D. The gradient is important. So at the point D, step number one, remember we need to draw a tangent at the point D. So the tangent will go parallel, which means the angle which this tangent is making with the x-axis is 0 degrees. Since the angle is 0, we can write the gradient of the graph at the point D will be tan 0, which is equal to 0. Now, let's figure out the gradient of the graph at the point B. Step number one, let's draw a tangent at the point B. So the tangent will look something like this. I have just drawn a rough diagram. So this is step number one. Step number two is let's try to identify the angle which this tangent is making with the x-axis. So this angle is close to 135 degrees. 135 degrees is 90 plus 45. So approximately I have taken 135 degrees, and tan of 135 is negative 1. Let me write this. Tan 135 will be negative 1, which means the gradient of the graph at the point B is equal to negative 1. Now remember this, the gradient at B is minus 1, gradient at D is 0. And let's go back to the question. Statement number 3, we need to identify the magnitudes of acceleration at the point D. So let me write the magnitude of the gradient at the point D, that is equal to 0, and the magnitude of the gradient at the point B. The absolute value of the gradient we had figured out was negative 1. If you take the magnitude of that, that will be equal to 1. And now we can see the gradient at the point D is lesser than the gradient at the point B. So which means statement number 3, which states that magnitude of acceleration at D is greater than at point B, that is incorrect. So statement 3 is also wrong, which means the right answer is option B. Only second statement is correct.